The final data structure that we will be working with is the hash table. Hash tables are very powerful data structures because they provide us with constant time lookup and insertion, or O of 1 runtime, which neither the linked list or the binary search tree can do for us. Hash tables are used for a wide variety of applications because they have a very fast runtime, and you will come across different implementations of them all throughout your programming. Hash tables are used to store data that is in the form of a key associated with a value. In many cases, the key will simply be a string, and the value will be any data type. Let's get into how our hash table will be set up and function. A hash table is simply a table of a predetermined length in which each of the cells of the table, or buckets as we will call them, holds a piece of data which has a key and a value. We will be using an array as our hash table, and each index of the array will be a bucket. Our array will start off empty, then we will fill it up as we add data to it. For this example, let's make a very small hash table of size 10. You can see that our hash table is an array and each of the buckets is initially empty. Now each piece of data that we insert into our table needs to be assigned to a different bucket. So how will we do that? We are going to take the key and hash it into a number. So let's say that we want to use our hash table as a phone book to store our friends' phone numbers in. The data that we want to store is an object with a key property and a value property, in which the key is our friend's name and the value is our friend's phone number. Let's take our friend Jim and his phone number of 555-2828 as our first piece of data. The first step is to hash our friend's name into a number that corresponds with one of the buckets in our array or our hash table. When we get into coding our hash table, we will write out a function that does this. But for the sake of this example, let's just say that the key Jim hashes into the value 8. So we will store this data as an object with key Jim and value 555-2828 in bucket 8 in our hash table. If we now wanted to insert our friend Brittany and her phone number into our hash table, the first thing that we would do is hash our key Brittany. Let's say that this gives us a value of 3, so we would store Brittany and her phone number in bucket 3. That is how we would insert data into our hash table. To retrieve data out of our hash table, we will write a get method that will take in the key of the data we are looking for. So now, if I wanted to look up Jim's phone number, I would take the key Jim and hash it again. Our hash method will give us the same number that we got the first time we hashed Jim, which was 8, so we can now go to bucket 8 and get Jim's phone number because it will be right there. Simple as that. That is how the main functionality of our hash table will work. Now, you might have thought to yourself, what happens if we have two keys that get hashed into the same bucket? Then what do we do? And that is a great question to ask. When multiple pieces of data are in the same bucket, we call it a collision. To handle collisions, we form each of our buckets into a simple list, so that if there is already a piece of data there, we simply chain what we want to insert at the end of our linked list. So let's say we want to add John and his phone number to our hash table. For the sake of this example, let's say that his key, John, also hashes to the bucket number 8. Since Jim's data is already in bucket number 8, we would simply start a chain at bucket 8 and link John at the end of the chain, like this. If we wanted to insert Becca into our hash table now, and she hashes to bucket 8 as well, we would simply run down our chain and attach her at the end. Now, to retrieve Becca's data out of our table, we would have to hash her key, which is the string Becca, go to the value we get, which would be bucket number 8, and travel through the chain until we find Becca's data. Now, as I mentioned earlier, hash tables are considered to have constant time insertion and lookup. But how can this be possible if we have to iterate through chains when we have collisions? And that is a good point. They are not exactly constant time lookup and insertion. But if you make a hash table correctly with many buckets and a good hashing function, you shouldn't get too many collisions. So that is why, on average, we consider hash tables to have constant time lookup and insertion. So that is how our hash table will be set up. The only operations that we are going to want to perform on our hash table are inserting data into it and getting data out of it. But in order to do these methods, we will need a third hashing method as well to hash our keys. For our purposes, we will be creating a hash table that stores our friends' email addresses. So we will have data in our hash table in which each piece of data has our friend's name as the key and their email address as the value. This is the hash table that we will be creating throughout this entire section. Let's start coding out our hash table in the next video.